Midtier is the main component users interact with Remediator system server, and therefore having an optimal configuration is a great starting point to offer the best possible experience to users. My name is Alejandro Vidaurri, and today we will talk about Midtier best practices. This agenda is a recollection of common areas where configuration can be improved, some learning experiences from actual cases, and a constant review with research and development and platinum engineering. We will cover from architecture through important configuration settings, operational cache settings, and useful logs in production. Here's the Midtier architecture, and it's a crucial point to understand where issues are happening and where preventive or corrective actions should be applied. The whole Midtier solution starts on the browser runtime. It would connect through HTTP or HTTPS and finally get to the web server OS, where initially the Java process will receive the request. The JSP engine, which is obviously a Java process, will pre-process the request, and finally Midtier application will produce a response with the help of AR system server information or maybe just the cache. But let's take a closer look. In here, we can see that a request is issued to Midtier. Then the security filters will review and pre-process it. Internal request handling will decide if this request requires cache information or maybe Remediator system information. Then the payload is prepared and it will make its way out as an HTTP response. Then the browser will receive the response and process it with its internal HTML, JavaScript, and CSS preprocessors, including the libraries that we ship with Midtier. The process actually ends when the browser shows the response to the end user. In this manner, if we're dealing with a performance issue, it may happen at maybe the browser, the Midtier server, the AR server, or the network. And usually architecture understanding and proper inquiries will help define where the problem is actually happening. Well, coming into compatibility, Midtier is compatible with modern major browsers. And keeping your browser updated to IE Edge or latest Chrome and Firefox versions is a very good practice. Mainly because the browser vendors also put their efforts to keep latest versions in optimal conditions. Java 64-bit is a requirement for Midtier, and we are in the process of certifying Java 9, but we're not there yet. Most common JSP engines are supported, and here's the list, and we're constantly reviewing latest versions and making sure they are compatible. Web servers are an optional component. Most customers prefer to have a second layer of control. Therefore, IAS and Apache can be configured to build the most robust solution. JAWS 16 is the screen reader Midtier compatible with, and for further or other components that you would need compatibility information for, please take a look at the Compatibility Matrix. Regarding the sizing, well, ideally, check your user requirements and go from there, and adjust the hardware as needed. Just consider that concurrent users is the number of users actually using the system at the single point in time. Let's say 800 users in an hour in the middle of your business day, compared to maybe 5,000 users that are listed in your user form. Once you have that number, take one size in this table and procure your servers accordingly. These numbers have been reviewed periodically for every major version, and most of them are also reported as part of BMC ITSM benchmarks and are available on BMC support site. So let's say you have defined that your concurrent users is 2,000, then you would need to adjust your keep alive count to 5,000 in your web proxy settings, and also your keep alive timeout in seconds to 60. And well, just making sure that you have 2 servers, 4 CPU cores, 12 gigabytes of RAM, and 60 gigabytes of disk space. We'll continue using the medium one for further examples, and then we'll review some configurations, sample configurations. On the JSP engine and Java Virtual Machine side, we configure some major areas, basically memory, garbage collection, error handling, and performance. And not having one of these areas properly configured will either not perform as intended or have lower chances of catching an error. So then some operating systems such as Solaris and Linux will require a few more settings to specify the 64-bit mode and the fonts for AWT are basically required for Unix and Linux, but mostly for reporting purposes. On the JSP engine side, the two main areas we're concerned about is the thread pool and the connection timeouts. And they are mainly focused on performance and volume handling. Well, this is basically the settings that are required for either your medium or small or large Midtier. So let's say we're sticking to the medium one. So make sure that you have 8 gigabytes set for the minimum and maximum settings. That's the XMX and XMS setting. Then the number of max threads that Tomcat should be handling is 2000. And regardless of the size that you have been allocating, well, make sure that you have all these in either Tomcat common settings or Java common settings, because they will just vary in the maximum amount of memory or the max threads, but then the remaining settings will be basically the same. Consider that these values are needed for Solaris and Unix only, and without them, a Solaris server will run in 32-bit mode, which is not really what we want. And without the AWT and font paths for web reports, they will cause some Java exceptions. Well, we have reviewed the Midtier servers, and we're assuming that they're properly configured. And it's a logical step, so just make sure that your servers are properly configured because moving into the load balancer settings. So let's review the architecture. You may have a load balancer in front of your Midtier servers, and I'm starting on the left. And that load balancer would be considered the HTTP load balancer. Then after the Midtiers, you may have another load balancer, and that be considered the Air server load balancer. And finally, that load balancer will reach to the Air servers. And from architecture perspective, it would go as mentioned, but we're marking them in very, very different colors, and that's on purpose, because they have different purposes, and they will have different policies and profiles. So even though both are considered load balancers, they would have very, very different behaviors. I'll start on the Midtier load balancer. And the session affinity should be turned on. Usually cookie-based policies is the best option. And what the load balancer will do is it will issue a cookie, and either the cookie has enough information to be routed to a single Midtier, or the load balancer will build a table to link a particular cookie value to a server. If the session is not sticky to one Midtier, then users will see session timeout errors, which is error code 9201, or it could be constantly redirected to RSSO pages if you're using Remedy single sign-on, or to logging pages. So if you start seeing a lot of logout timeout errors, take a closer look at your session affinity. If these issues are happening, BMC support will request logs to confirm if session affinity is honored. And if not, well, the evidence will be shared with you, but basically we'll need the load balancer administrators to take a closer look at why this session affinity is not honored, and we will have IP to IP information to prove that. On the other side, on the white load balancer that's meant to be for Azure server, it does not require session affinity. And that part can be handled by Midtier connection settings. However, the load balancer is still needed to resolve the IP addresses of all the Azure servers in the server group. If there is an F5, one connect and HTTP profile should be disabled. So just consider that there are two very different load balancers. Lastly, if there is a network misconfiguration, it will impact the system performance or even render it unstable. We've seen situations where the MTU values are causing packet fragmentation, and in some other cases, the VIP or WIP policies create unnecessary loops. So make sure your network is properly configured, including your VIP policies. Now that the servers and infrastructures have been reviewed, let's dig into the Midtier application settings. Midtier cache has been greatly improved and has become a lot more complex. We have gone from prefetch to now preload. And preload is a feature that will use statistics to build all the active links and associated forms into cache. This is an intensive process, and you would see benefits of it in the early setup of your Midtier. But once cache has been built with most common use forms, keeping it enabled will just run unnecessary validations to your server and cache. So turn it off as soon as your system is stable and restarts are no longer needed. Cache persistence should be turned on. It will save cache information to disk, and when a normal shutdown happens, cache will be in good conditions to be reused from disk instead of rebuilding it from the AR server. Consider that an ITSM application can build near 2 gigabytes of form and active links data into disk. And without this feature, all that amount of data will be reread from the AR server. The resource check interval needs to stay enabled, but it needs to have a higher value, like 1,000 days, as in this example. If we keep it at the default values, 86,400, it will cause Midtiers to check back with the Azure server on a daily basis for changes. And if a new object is detected or a change has been detected, then it will be cached, and if that operation, that caching operation, happens in the middle of the business day, it will slow down Midtier. So increase this value to 1,000 days, and you will keep sync cache feature, and will also lower the probability of caching during business hours. So make sure that your configuration is properly set in these areas. It has been slightly confusing for some customers. So these values have been reviewed, and making sure they're properly set has been very, very beneficial to most of our customers. So now that we're talking about cache, let's go into the flushing cache operations. Why do we need to flush the cache? Usually because we have something new on the server, or some changes have happened, and we need to make sure that those changes or new objects are properly stored into the Midtier server before the users actually come in. So we have 4 options to do this. There's the first one is a new page that's accessible from the config.jsp page. So once you log in into config page, just modify the URL to get to config_cache_cleanup.jsp page. In there, you will find a menu that will list all the Azure servers, and you just need to select the Azure server and enter the form that you want to flush. And this is very helpful if, let's say, you're developing a form and you have made changes to that single form. Instead of flushing the whole cache, you just flush that individual form cache, and you will see the changes the next time you access that form. On the other hand, if you have more than a handful of forms with active links, it makes most sense to do a sync cache. So it will ask for all the modifications or new objects after the last flush, and then everything will be all the new objects or changed objects will be rebuilt into cache. So that can be helpful for a little bit more forms, a little bit more active links. On the other hand, if you see a lot of errors or your cache has not been properly synced, well, flushing the cache makes a little bit more sense because it will clear everything but not the stats, and rebuild everything from there. The statistics will prevail, so it will start rebuilding based on the most common use forms. If all these three initial processes do not render the desired result, the last option is to do a hard cache flush. It's basically a manual procedure that requires a restart, and you will delete mainly the cache folder, the plugin definitions cache folders, and also the view stats. Deleting the view stats is required because then the statistics will be in sync. Not deleting the view stats can cause some issues. So use this as a last option, involve support if needed. Well, let's say your system is up and running, your Tomcat settings, your Java settings, your network settings are fine, and finally your cache is operational. So what would be useful if you are now in production but are afraid that something may happen, or you want to be prepared if something happens? So these are the most common use categories: cache, session management, performance, and servlet. Having a log level set to fine and log format set to detailed text. This has been very useful for a lot of customers that have had issues. So having less details or less categories may not give us enough information to actually act upon a situation. And if you want to have more log categories enabled, that can be useful for particular situations, such as web services or reporting, or let's say maybe workflow or your system performance. But keeping the configuration on the log settings as this has been very, very helpful. Finally, please stay updated. We are addressing defects and we're improving the system in several ways on each release, so please stay updated. The Midtier server can be updated in a small window change. So a Midtier server can be upgraded in a small change window. So it will require stopping a server, replacing the files, clearing the cache, and starting the server. And well, depending on your mileage, that can be done in less than an hour. The 9x hotfixes can be found at this address, so you may just need to hop in and see if there's a hotfix. All the hotfixes are accompanied by a README file that says which situations have been fixed or improved. So take a look at that and stay updated. Well, the content of this presentation has been based on these two articles. They are both constantly checked by research and development, but also for the web team. And they are very much updated, so take a look at them if you have further questions. And thank you for your time.